So thank you very much for being here with us, for having us.
Absolutely.
I'm Natalia, Natalia Venditto. I work at Microsoft in developer tools and experiences for JavaScript. And I'm here with Ralph.
That's right. I'm Ralph Squillace. I work in Azure Core, upstream, open source. And we're going to talk about debugging in WebAssembly.
That's right. And I want to make a disclaimer that I do not work in WebAssembly full-time. In fact, I mostly don't work in WebAssembly. I just work with WebAssembly occasionally. And maybe you're thinking, OK, what is she doing here on stage, trying to teach us something? I think that from building, we learn, right? And we learn the gaps. We learn what we can do better. And this is what we're here for, right? To make this technology that is amazing already even more amazing. Why do I work with WebAssembly if I'm not a WebAssembly developer or work at a low level? I work in JavaScript. Because there are two promises of the technology that I especially like. One is performance. The other one is portability. Working in developer tools, making sure that developers can build applications and take them from their development environment to the cloud and run them and debug whatever happens there is very important. And so if I'm a JavaScript developer and I want to work with WebAssembly, and I'm building an application, I'm designing it, I'm responsible for the whole flow, what are two main challenges? We have the part where I have to decide what goes in a WebAssembly module and what's part of the JavaScript standard, and the debugging part. I have more layers, and some of those layers may not be right away accessible to me, or I may not know how to do that, right? I have to learn new things. But what I know is that I want to be building in a familiar context. Almost 100% of the JavaScript developers, we ask, what's their favorite editor? They say VS Code. This is where they want to stay at during the whole flow. When they're building, when they're deploying, when they're already in the cloud, and they're debugging. And of course, the browser. The browser has been my environment as a JavaScript developer forever. I know it. I know the tools. I know how to use it. And so let's use it. And this is a demo we have for you today. We are going to do a little bit of role play. So I'm the front-end developer. Ralph is my back-end developer.
Which doesn't bode well.
Yeah. So he sent me this module that I'm supposed to be importing to my JavaScript application. Let me go to VS Code, if I can find it. Where are you? Over here. You tell me if you can see, if I need to zoom in. Is it fine? Zoom in, OK. That OK? Yeah? So, oops, I'm struggling with my microphone. So this is a Vite application, right? It's JavaScript, but I am building it with Vite. And to begin with, you notice I had to add a couple of plugins to the Vite configuration in order for it to understand what's Wasm, what I'm going to be doing. So I have this Wasm plugin and this top-level await as well that need to be there, otherwise things won't work. And when I first built this application with JavaScript without Vite, and I started a Python server, everything worked. But once I installed Vite, the story was different. So point number one, I already have something else to do that I may not need to do for a regular application. Now, I've been told that he did this, because he's the one building this module, right? Let me see. So the first thing, he built this module with a target wasm32-unknown unknown. Why? Because I want to debug it later in the browser and in VS Code. And for that, it needs to be compiled in this way. So that's it. We have the target over here. But that's not enough, because I need additional information. He told me something about some dwarf symbols. That may be very familiar to all of you or some of you. For a JavaScript developer, dwarf symbols? I don't know. I never heard of that. But we need them if we want to debug this application. So we're going to be installing. Let me make more room for the console. We're going to be installing this. Wasm I, keep debug, all these flags. OK? Now I have a package with this library. And I'm going to run the debugger for the first time. First of all, let's start the server. OK, feed is running. We have a local host. I'm going to go there. And, woof. Why doesn't want to click it? Click it. OK. So let me open the developer tools over here. There is already an error. The requested module, blah, 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 does not provide an export name, blah. That's because this is how it's being distributed. If I go to the package, I have all these files, and I have this barrel file that I don't know if I have control over, but it looks like this. There is no export package. So this is when I have to, and I'm going to go to my backups, do this little modification here, this refactoring, and go to my, oh my God, I can't see anything. There you go. So now I suppose that I go back to the browser, wherever it was, here. The error is gone. And this is just a translator tool, so we can be cool. Like I pass any string in UTF-8, and it's going to show me the representation in binary, right? But they told me also, if you add special characters, it breaks. So you have to show that in the UI, as a good front-end developer would. And I first test it for it to work. I say hello. It works. Then I say, OK, hello, Ralph. Thanks for the module. Translate to binary. It doesn't. I'm clicking. There was an error, caught in promise, whatever. What's the error? I don't know. But because we added this dwarf information, we can go and check. Where? Let's go to VS Code, where I want to say, because that's my environment, where I am used to working. And let's go to the debugger. And let's launch it. It's just a Chrome one. It goes here. Let me do it, because I love it more in the Canary. And let me bring in the inspector. And sorry, because I am on a small screen, so I'm going to try to make it more.
To the back-end developer, this is already magic to me. Right? Like, I don't know. This is just amazing.
So wait a second. Where is it? I want to see it in the console. So you see that, yeah, didn't find the server at the beginning, but that's OK. You see this, C that /C++. First of all, it's naming, OK? You may say, like, Natalia, don't be so picky because you know that you're debugging WebAssembly. And yeah, but for a front-end developer, this may be a little bit confusing. I have something in my browser that it's supposed to help me debug a module that I know was built in Rust, but it's talking about C++. So now, if I go back to the editor, since I have this session running, let's see if we can debug it. So, OK. Yeah, everything is running. I'm in the right one. Yeah, let's say hello, and let's add some special characters, and then say translate to binary. And you see immediately in the browser, it went to the Rust into the Rust source. And if we go back here, I don't know what is not. Maybe because I reopened it. Or maybe because the demo gods always play tricks with us. But let's stop it and let's start again. Launch. Hello. No, there you go. So now we are debugging in VS Code. And I'm going to continue to step into, oh, see, this is new. It depends on if you step into or step over how fast you're going to get here. I wanted to show you the whole flow where I go over the WAT file, which obviously for a front-end developer, S expressions are unreadable and don't mean a lot and don't help a lot. But at least I know it should be an alphanumeric thing, and why when I add a special character, it's breaking. That's an exception. That's a bug, actually, because even though it's a special character, the user should be able to translate whatever phrase they want, even with spaces. And so I'm going to go back to my backend developer. But I have, one second, I have more stuff to talk about. Backend developer has to wait. So we've seen that we can go through a debugging flow. And I want to go back to my presentation. Where is it? Did I close it? What did I do with it? No, it's here. OK. I don't know if I'm going to be able to make it bigger now, like full screen, but this works. There you go. So key takeaways. This flow assumes a lot from the side of the authors, maybe, that the developer knows what dwarf symbols are and that they know what tooling they need to use to embed them. And we also realized that making that Wasm or importing a Wasm module and making it functional implies front-end developers need to install additional plugins in their front-end setup, and that they may be able to understand the information that the WAT is delivering. It's not the most straightforward debugging experience. So how could we make this better? Well, we could consolidate the end-to-end debugging experience from editor to browser to server. Mm-hmm. We could reduce the number of very specific tools and technologies that we need to install or deliberately install for the developers to be able to go and find an issue in their applications. And we need to be able to unify the supporting environment for portability. And that's something that it's going to be more evident when Ralph starts his debugging experience. But finally, from my end, if I can make this work, it doesn't want to. Ooh. OK. Let's go forward. Oh, it doesn't want to.
You're stuck?
It's stuck in this slide. Let's escape. And let's go here.
There you go.
It's because probably my phone went offline.
Anyway,
what I wanted to say is that I wanted to also componentize, because the component model is the way to go forward. But for me, as a front-end developer, writing with and this is something I shared already with relevant people that are here today, it's not also something very simple or intuitive or something I'm used to. So if I have to pass, let's assume I'm using componentized.js, and I have to pass as sources my JavaScript, it's fine. But then I also have to pass the contracting with. It may not be the most straightforward way. And I want to show the next slide, Ralph, but maybe we switch to Ralph's computer.
Sure. Switch over, because that'll be the next slide.
Yeah, that's online.
And we'll go back.
So I think the team can do that for us.
So when you switch to the other feed, yep, and we'll go
Can you go?
back.
Yeah, can you? Yeah. So this is like no, the next one.
There you go.
Yeah. So this is what what I meant, right? If I have to export this JavaScript function and I have to pass also the with contract for the tooling to understand what I want to do in a component model strategy or context, this is a simple one, but we know that not all the widths look like this. And this may not be as straightforward. But if I would be using a tool like this one, and I want to give a shout out to our colleague Brian Terrelson, who is one of the creators of TypeSpec at Microsoft. It's an open source tool to create API shapes and interfaces. And if we were going to use, I don't know, decorators, for example, that would be a lot more intuitive and familiar for the JavaScript/TypeScript community. And now, yes, I'm going to pass the microphone to Ralph.
So first of all, thank you very much. From being in the WebAssembly community for a while and working with many languages and features, one of the most interesting things is that Natalia was able to do this at all and wire it all up through VS Code to kind of dance from one environment to another and actually step through the Rust. Now, the Rust may or may not mean a lot to her, and if she steps too far, she might dump into the Wat, which is completely incomprehensible to most people. They want to use the features. They don't want to read the features at the bottom level, right? So it's first and foremost fantastic. But then, in our role, Natalia says, hey, Ralph, I found this bug. Can you go back and fix that? But now I'm the Rust developer, or C, or Go, whatever it might be. I don't want to build the JavaScript app to find the bug. And how do I do that? Right? Well, let's start off from that point, right? I need to be able to debug Dwarf. She was using a Dwarf prototype, an early version of Dwarf debugger from VS Code. She files a work item. I got to go fix the problem. So where do we pick up? It should be possible. Is it? Yes, it's actually possible. This is a cool thing that we've actually made a lot of progress here. I should grab the function code. I should build a local entry point. I should just wire up the debugger, and it should just work, right? No, not quite that easy. And a lot of us here may know this, but it's actually better than that. Let's start with the binary translator that we just saw. So I'm going to bounce out of this, and we'll go here. Go ahead and show this screen. Do I have to tear down the sharing? I probably do. Right? And we'll go ahead and bounce out of that. We go to the demo. So here I am. All of these repositories that I'm going to dance through today, about 5 of them, maybe more, are available on GitHub. Natalia's application is available on GitHub, so you're going to be able to pull this and play with it. Hopefully break it, submit fixes, and so on. But generally speaking, I need to find where we built that WebAssembly, and it's going to be in binary translate, and I'm going to open up code because I need an editor. This could be any editor. It just so happens that I use code, partly because I might actually work for Microsoft. But it really should not matter which editor it is. So here's my code, and the first thing you'll notice is that this is actually the function she was stepping through, word to binary. But interestingly, it's not in the same project structure. So the first thing I have to do in the current environment, working backwards to a debugging story, is I have to build my own entry point. in Rust. But I want to take the exact same function she had. So we've got the with bindgen prelude up there. We've got to make sure we have the JS value types and so forth. This would not be the way you would build it from scratch. Instead, you would probably have a library and a crate, and then have different build pipelines out to a debug environment or to the JavaScript application that she had. But for the sake of discussion, what we've got here is something that we need. And what we're going to do is launch it. And I want to point out that we're going to launch it with LLDB. So this is public debugger, this is open source, this will run anywhere. What we don't want to do is step through LLDB on the command line. Because it turns out that for whatever reason, every 3 days you will magically forget those commands. So what we want to do, we want this thing to work for us in VS Code. And it should. We go ahead and build it, right? And pops up into the main. This is the fake entry point. So we'll go and step into the function. Sure enough. Now, the string I passed to debug is a valid string. So in this case, if I let it run, it should just go through. And it does. Goes ahead and terminates. Yay, it worked. I'm gold. But now I want to do the failure case. So the failure case is we throw a few other things in there. We go ahead and restart the debugging. From my perspective, everything is native code. This is just Rust, right? And I'm in VS Code. And from a standpoint of developing things for consoles, servers, and so forth, where you don't have a UX on top, there's no display presentation that I'm working through right here, this is actually a native experience. And it's actually okay, which is kind of surprising. So if I go ahead and step from there, I'm in here. You can see that if these chars, if I get through these chars, even the watch values are going to resolve for me. So far, it looks pretty good. So if I can go ahead and step through, and I hit the error value. So I know that this is going to be where I'm catching the bug. I can actually go ahead and debug. And if I go ahead and let it run to handle the error, because you can see that up here I'm handling the error, everything's great. Wait, oh, not so great. Okay, we understand what happened. Or do we? The actual fact is we've run into the first problem. So the first problem is that when you're compiling to unknown with the recent versions of Rust, with bindgen does not build in the implementation for JS value. So the string where I want to get the error value in JavaScript types does not resolve and it fails. We can resolve this, but the first lesson we learn is depending which tool chain you're building your WebAssembly, the debugger will or will not understand everything that has happened in that tool chain to result in the WebAssembly you're building. Notice, Natalia did not have that failure. And the reason is because in her compilation, the Wasm bindgen did provide that implementation, and so she was able to see the error type. So that's the first lesson, is we have to realize that Wasm bindgen was built several years ago, and so if I used a Rust, and I did verify this, if I use an earlier Rust, that actual implementation does get built into the WebAssembly module, and it does resolve in the debugger, which is great. So we've got an incomplete but workable experience on the server. But that's a kind of contrived example. I can fix now the code, I can republish the WebAssembly, and Natalia's off to the races with her billion-dollar-making word-to-binary translator application. Fantastic. So if we go back, however, what we want to see is, we want to see, can I do this more generally across languages? And there's been a lot of work being done in the debugging space, and there are many presentations that have gone on over the last year, several of which are fantastic. But let's just try Rust, because why not? We've got several versions here. Now, this is a general experience. I want to show you what's happening. So in the launch configuration, I have the code LLDB and LLDB installed. So we're going to do two different debuggers. We're going to do LLDB, and we're going to debug the same application with GDB, so you can get a sense of the different experience. And both of them are going to go ahead and launch down here, The build process, that build process is here in tasks. You can see that we're just compiling out. Notice this is a core Wasm module. That is, it's preview 1. It is not a components module. And that's going to be important. So we go ahead, and if we set some breakpoints, we should be able to go ahead, and we could do GDB first, but I want to do LLDB first. And the reason is because we can actually have a real experience here. So it goes ahead and breaks. You can see on the left that you can set watch points and so forth, right? We've got some values. They all resolve. If I go and jump into the function, pardon me, I can go ahead and do that. The watches now are out of scope, so they're not there. And I can step through to my heart's content. I can write a line, and we can come back out, and then we've written this, and so forth. If we go down to the terminal, right, you can see it's almost there. We go ahead and let it rip through. Fantastic. It works. So this is just a standard setup. So if you're doing Rust work into anything that is not a component model component, right, you can take this repo and the setup, and it'll just work. It'll just work, which is fantastic. But you say, I use GDB. I really like GDB. Okay, fine. Will it work with GDB? The experience is slightly different, right? It comes up, it catches that. Notice that these can't be resolved. So GDB is interpreting the dwarf in the Rust slightly differently and is unable to resolve the types. Notice also we don't have any locals up here. We can, in fact, step through, but at no time do we get the type unwrapping that we need to understand what's going on. So there's a difference in the way that GDB and LLDB are interpreting the dwarf that the Rust toolchain brings into the module. That's important. But it does work. But we can do other things. So we can go back to here. We will do C and C++. I just want to make sure that you get an understanding of how this works. We're probably going to go right up to the end of the presentation here, but I want to make sure that everybody sees it. Now, for here, I've implemented both C and C++ with both GDB and LLDB. This, again, is just a repo. These are just configurations right here. We're just using, this is all open source. This will work in JetBrains. It'll work in pretty much anything else, right? Some configuration tasks may be different. They may be shaped different. Any IDE should be able to do this. So if we want to do C, we're already using C LLDB. We go ahead and build, pops in. We've got a buffer here. If we step through and go here, at some point, we're going to set the buffer right there. Sure enough, it populates. We can see the values. So we're getting close to what seems like an absolutely beautiful native experience. We stop, because it's going to work. And we go ahead and try GDB. There we go. And it works, except the buffer renders differently. Again, we've got a difference in the debuggers understanding the format of the dwarf that's been embedded by the toolchain. Now, this is C and C++, not Rust. And yet we get a very similar slight mismatch between the two debuggers. It'll be really interesting. I didn't get a chance to finish off the Go with Delve. I'm really looking forward to a little bit of time before KubeCon in Paris. And I'm going to get that all set up. I want to see how the Delve interprets the Go dwarf toolchain. We can also just go ahead for fun. I'm going to just do one. You imagine that this is probably going to work the same way. We're going to pop in to the CPP file, and we get the same experience. But you'll notice that the resolution over here is slightly different, right? So if we keep going, we step through, this is really the same code, right? And if we get through the buffer, sure enough, it resolves in the watch area over there. So the experience is very straightforward. But there are small differences. So in all experiences, we get this, essentially, this is the context of the runtime. In this case, you saw that I was launching Wasm time. LLDB and GDB don't care which process I'm using for my runtime. What happens is they compile everything out eventually into a native engine, and they have to pass the debugging info into that binary. And LLDB just attaches to processes. So it's not debugging Wasm time per se, and it wouldn't be debugging any runtime here. Was0, Wasmer, Whammer should all work this way. This means that it's possible to do debugging generally with these language chains and not be concerned about a specific runtime. Another way of saying it is all runtimes get the same support. That's really cool. Now, before I close up, because I can show you a whole bunch of problems as well, I want to make sure that we get through to what is really closer, but still a dumpster fire a little bit. And as we keep going, we're going to get to a place where Natalia is absolutely right about how to make this better, right? But the details are, we need to, all the Wasm runtimes need to make sure that we get symbol-friendly support for both core WebAssembly and components, which are a different file format, into the eventual compilation of the native binary. We need to make sure that VS Code and other IDEs have easy templated ways to do what I did right there. You should be able to just grab it and make it work. And we have to enable symbol files outside separately. That work is being done, and you can join it. So the Bytecode Alliance Foundation has a SIG debugging. There is a new RFC just this week that proposes a way to begin working using Wasm time as an example, with the ultimate goal of having a generic a generic debugging API, allowing all runtimes to maintain their current debugging API, but at the same time, standardizing the ability of components to plug into those APIs. That's a really great path. If you'd like to join it, that work is ongoing here. This is the RFC right over here. I will leave that up there when we're done. The repos that you saw here are right there in my GitHub organization. Natalia's application is right there in her GitHub organization. And we want to thank you very much. If there's any time for questions, we're here.
This is really nice. Details, is this basically going to roll into VS Code JS debug? Is it running on like debug adapter protocol? Can I roll it into NeoVim? Am I talking rubbish? Like,
say that again?
So is this like your integration to VS Code?
Yeah.
Is like, so VS Code JS debug, I think your JS debug modules, that's all open source. That speaks that debug adapter protocol thing, which I think is a Microsoft thing. Is that how, when you talk about it integrating with all the IDEs, is that the mechanism by which you're doing it? Because there's like...
So LLDB and GDB, the demos that I showed you, and this is actually the same process that Natalia's Rust portion used. Okay. The LLDB one is not a debug server protocol, not a debug adapter protocol. Okay. It's actually just a process. It's running, I could run the same commands on the command line. But the problem is that I will forget those magic commands to set breakpoints and examine memory and stuff. Like, there's no way I would ever remember that stuff. That's just, maybe it's because I'm getting on in years. I'm not sure. But no, this is not a debug adapter. What the proposal is, one part of the proposal is to actually build a standard debug adapter for VS Code, but the debug adapter protocol is actually pretty widespread now, and it's not, even though it's originated with the VS Code project, it's widespread and is used by lots of different IDEs.
Yeah, that's what else.
Yeah, exactly. And everything we showed here is open source, right? There's nothing, like, we're not running on Azure or anything like that. It's all just the stuff we use every day as developers.
Thank you.
Yeah, I had another question. So, right here.
Yeah. There we go.
Yeah. So, was more of a question. Was more like a comment on the demo. You show the C application being debugging with GDB. You showed that when you were watching the array of chars, they were listed as a list, and when you were showing them in LLDB, you could see like the complete string.
Yeah.
What I typically do when I debug with GDB is to cast explicitly from an array to a pointer, because well,
Yes.
arrays are not pointers. There are some subtle differences. This
Right.
is why
Right.
I guess that GDB is interpreting this differently.
So there are two things that going on there at least, and there could be more that I'm ignorant of. One thing is that the Wasm time is responsible for projecting that debug information into the ultimate compiled item, right? But the other, but part of that process is Wasm time knows what those types are. And it may be rendering extra information or not rendering extra information that allows those debuggers to display them in a more human-friendly way. So some of the work items for the debugging experiment that we're doing in the Bytecode Alliance involve teaching Wasm time. There's a PR out now involving teaching Wasm time to express this type information more clearly and normally WebAssembly runtime will try and optimize out as much as it can. But in a debug mode, you don't want that. You actually want to inject more type information that allows the debugger to just automatically unwrap that array, that pointer to an array into an actual string. Because Wasm time knows, but LLDB doesn't, or GDB, for example.
Okay.
So that's sort of what an area in there that the work has to be done.
Okay, thank you very much.
Mm-hmm. I'm sure there's more debugging questions. But we'll be available outside. Thank you very much.
Thank you.